For each statement below, indicate whether the answer is true or false. Vertical scaling focuses on adding more servers to balance load. The answer is false. Horizontal scaling can help handle traffic spikes by adding more virtual machines. The answer is true. High availability guarantees that services will never experience downtime. The answer is false. Reliability in the cloud is achieved by deploying resources across multiple regions. The answer is true. Now let's explain why these answers are correct. Starting with the first statement, vertical scaling is actually about increasing the power of an individual server, like upgrading the CPU or RAM, not adding more servers. So, the idea of adding servers is horizontal scaling, not vertical. Next, horizontal scaling involves adding more virtual machines or servers to handle increased traffic. This allows you to spread the load across multiple resources, which is an effective strategy during traffic spikes. Now, although high availability is designed to reduce downtime and improve system resilience, it doesn't guarantee 100% uptime. Systems can still go down due to unexpected issues like bugs or network failures, even with high availability in place. Finally, cloud reliability is greatly enhanced by spreading resources across different geographic regions. This way, if one region experiences an issue, like a power outage or natural disaster, other regions can keep the service running. This geographic distribution is key to cloud reliability. So that wraps up this question. For each statement below, indicate whether the answer is true or false. A hybrid cloud allows organizations to move workloads between public and private cloud environments. The answer is true. Hybrid clouds are ideal for companies that require full control over all their workloads. The answer is false. Hybrid clouds are less flexible than private clouds alone. The answer is false. Hybrid clouds can be used to extend a private cloud's capacity when demand surges. The answer is true. Let's now take a moment to explain why these answers are correct. First, one of the main benefits of hybrid cloud environments is the ability to move workloads between public and private infrastructure. This gives organizations flexibility in how they manage resources based on current needs. Next, although hybrid clouds offer flexibility, they don't provide full control over everything. The public cloud portion is still managed by the cloud provider, which limits how much control a company can have. That's why they are not ideal for businesses needing total control. Now, contrary to what the third statement says, hybrid clouds are actually more flexible than private clouds. This is because they combine both private and public cloud resources, allowing organizations to scale and adapt quickly. Finally, hybrid clouds are especially helpful when private cloud capacity is maxed out. During high demand periods, businesses can tap into the public cloud to handle the extra load, which makes hybrid clouds a smart option for scaling. And that wraps up this question. For each statement below, indicate whether the answer is true or false. IaaS is a good option for lift and shift migrations from on-premises to the cloud. The answer is true. IaaS is not suitable for development and testing environments. The answer is false. Organizations can scale resources up or down quickly in an IaaS environment. The answer is true. IaaS is designed primarily for users who want a fully managed infrastructure with minimal user responsibility. The answer is false. Now let's go through the explanation to understand why these answers are correct. To begin with, IaaS, or Infrastructure as a Service, is perfect for lift and shift migrations because it allows organizations to move their existing infrastructure to the cloud with minimal changes. This makes it a convenient option for businesses looking to transition from on-premises environments without redesigning their applications. Next, the idea that IaaS is not suitable for development and testing is incorrect. In fact, it's one of the most common use cases for IaaS because developers can quickly spin up virtual machines, test code, and shut down resources when done, all without long-term commitments. Moving on, one of the biggest strengths of IaaS is its scalability. Companies can scale resources up during high demand periods and scale down when they're not needed. This pay-as-you-go model offers both cost savings and flexibility. Finally, IaaS is not a fully managed solution. Unlike PaaS or SaaS, where most of the infrastructure is managed for the user, IaaS gives full control over operating systems, storage, and applications. However, with that control comes greater responsibility for management and maintenance. That's the breakdown for this question. Fill in the blank by selecting the correct options from the drop-down menu. Azure App Service allows developers to focus on application code while Azure manages the infrastructure. Serverless compute solutions like Azure Functions execute based on event triggers rather than persistent server allocation. Now let's go ahead and explain why these answers are correct. To begin with, Azure App Service is designed to simplify development by letting developers concentrate on writing their application logic. They don't need to worry about managing servers, patching, or scaling. That's all handled by Azure. That's why application code is the right choice here. Meanwhile, Azure takes care of the infrastructure, which includes provisioning servers, maintaining operating systems, and handling runtime updates. Next, when we talk about serverless compute options, Azure Functions is the most fitting example. It allows developers to run small pieces of code or functions in response to events without managing any server infrastructure. Lastly, those functions run on event triggers, meaning they only execute when something specific happens, such as an HTTP request or a message in a queue. This approach is efficient because it avoids the need for always-on servers, which also helps control costs. And that's how everything fits together in this fill-in-the-blank question. For each availability concept listed below the table, drag it to the appropriate boxes in the correct match column to match it against its description in the option column. Redundant regions to ensure uptime. The correct match is high availability. System recovers from failure quickly. The correct match is reliability. Global scale with automatic failover. The correct match is high availability. Continues functioning despite disruption. The correct match is reliability. Increased resources to handle demand. The correct match is high availability. Let's go ahead and explain why these answers are correct. Starting with redundant regions to ensure uptime, this is all about high availability. By deploying services in multiple regions, the system can stay up even if one region goes down. Now, when a system recovers from failure quickly, that describes reliability. It's not just about staying online, but bouncing back smoothly after something goes wrong. Next, global scale with automatic failover clearly fits high availability because it allows workloads to shift automatically to another region without manual intervention, minimizing downtime. Meanwhile, the phrase continues functioning despite disruption highlights reliability as it speaks to the system's ability to maintain operations under adverse conditions. Lastly, increased resources to handle demand fits under high availability. During traffic spikes, having more resources keeps services running efficiently without delays or crashes. And that wraps up this matching activity. Which type of cloud service model is typically licensed through a monthly or annual subscription? Select only one answer. A, infrastructure as a service, IaaS. B, platform as a service. C, software as a service, SaaS. The correct answer is C, software as a service. Now let's explain why this is the correct choice. SaaS is a cloud model where software is hosted centrally and accessed over the internet. Think of tools like Microsoft 365 or Google Workspace. These are typically offered through monthly or annual subscriptions, giving users continuous access to the latest features without needing to manage the software themselves. On the other hand, IaaS and PaaS operate on a pay-as-you-go model. With IaaS, you're billed based on the virtual machines, storage, or network resources you consume. PaaS, similarly, charges you based on your usage of development tools and services, not a fixed subscription. So if you're using a tool that feels like a regular app with a subscription model, you're most likely dealing with SaaS. That's what makes it the best answer for this question. A company has deployed an application on an infrastructure as a service, IaaS platform. Which of the following are responsibilities of the company under the shared responsibility model? Each correct answer presents a complete solution. A, patching the virtual machine's operating system. B, managing the data stored in the application. C, ensuring the physical security of the data center. D, implementing identity and access management for users. The correct answers are A, patching the virtual machine's operating system, B, managing the data stored in the application, and D, implementing identity and access management for users. Now let's explain each of these answers clearly. In the IaaS model, the cloud provider manages the underlying hardware, networking, and physical data centers, but the customer is responsible for the virtual machine environment. That's why patching the virtual machine's operating system is the customer's job. They need to ensure the OS is secure and up to date. Next, the company must manage the data stored within its applications. This includes backups, encryption, and applying the right access controls to protect that data. Also, implementing identity and access management is a core customer responsibility. The company must control who has access to the system and what level of access each user has. This helps secure the applications and data from unauthorized use. However, ensuring the physical security of the data center falls under the provider's responsibilities. They manage the cameras, guards, gates, and environmental safeguards. So, under the shared responsibility model in IaaS, the company takes care of software and access, while the provider handles the physical infrastructure. If a business-critical application runs on a service with a 99.9% SLA, how much downtime is acceptable over a month without breaching the SLA? A, 4.322 minutes, B, 43.2 minutes, C, 7.2 hours, D, 1.6 hours. The correct answer is B, 43.2 minutes. Let's now break down the explanation for better understanding. A 99.9% SLA, or service level agreement, means the provider guarantees the service will be available 99.9% of the time during a given month. Now, there are about 43,800 minutes in a 30-day month. So if we calculate 0.1% of that, we get roughly 43.8 minutes of allowable downtime. Rounded slightly, this becomes 43.2 minutes. Next, looking at option A, 4.32 minutes, that's far too strict. That would be closer to a 99.99% SLA. Options C and D, 7.2 hours and 1.6 hours respectively, both exceed the downtime limit for 99.9% uptime, which would breach the agreement. So, if your service goes down for 43.2 minutes or less in a month, you're still within the terms of a 99.9% SLA. Anything beyond that could be considered a breach of contract. Which of the following best describes the governance benefits of the cloud? Select two answers. A, cloud-based auditing flags non-compliant resources and suggests mitigation strategies. B, governance updates must be manually applied to all cloud resources. C, governance standards can be automatically applied and updated across all resources. D, governance ensures that resources are only compliant with the initial deployment standards. The correct answers are A, cloud-based auditing flags non-compliant resources and suggests mitigation strategies, and C, governance standards can be automatically applied and updated across all resources. Now let's walk through the explanation to understand why. Cloud-based auditing is one of the key governance benefits. It allows platforms like Azure Policy or AWS Config to continuously monitor cloud resources, detect when something is out of compliance, and either recommend actions or automatically enforce corrections. This makes it much easier to maintain governance without constant manual checks. Additionally, one of the strengths of cloud governance is automation. Instead of manually applying policies every time there's a change, cloud services let you set standards that automatically apply across all relevant resources. This helps organizations stay compliant as they scale or update infrastructure. In contrast, option B is incorrect because manual updates are not required in modern cloud environments where automation is built in, and D is also incorrect as cloud governance supports ongoing compliance, not just at the initial setup. So those are the two major governance benefits that make cloud platforms both powerful and secure. You need to upload a new image file into an Azure storage account. Using the provided image, identify the first step to access the area where you can upload the image. Task: drag and drop the marker labeled "Click Here" onto the correct area within a red bordered area. Let's break this down to make sure we understand the task. In the image, we can see the Azure portal interface, and the first step for uploading an image into the Azure storage account is to navigate to the Container section under Data Storage. This is the area where files like images are typically stored and managed. After clicking on Containers, you will be directed to the section where you can create a new container or manage existing ones. This is where you can upload your image file, so this is where the Click Here marker should be placed. Now, let's walk through the process. 1. First, click on Containers. 2. Then select the container you want to use or create a new one. 3. After selecting the container, you will see options like Upload, which will allow you to add your image. So the correct first step is to click on Containers. After that, you can proceed to the Upload option. For each statement below, indicate whether the answer is true or false. Azure Virtual Desktop provides a cloud-hosted version of Windows that can be accessed from any device. The answer is true. With Azure Virtual Desktop, all user data is stored locally on the device. The answer is false. Azure Virtual Desktop supports both single and multi-session Windows deployments. The answer is true. Role-based access control, RBAC, and multi-factor authentication can enhance security for Azure Virtual Desktop users. The answer is true. Let's now go through the explanation together. To begin with, Azure Virtual Desktop is designed to provide a full Windows desktop experience from the cloud, accessible on multiple platforms like mobile devices, tablets, and browsers. This allows users to work from anywhere with a stable internet connection. Next, the idea that all user data is stored locally is incorrect. In fact, Azure Virtual Desktop stores data and applications in the cloud, not on the user's device. This separation increases security and minimizes the risk of data loss from lost or stolen hardware. Moving on, Azure Virtual Desktop supports both single-session and multi-session deployments. This means it can serve individual users or allow multiple users to share the same virtual machine, making it cost-effective for organizations. Lastly, security can be significantly strengthened using Microsoft Entra ID, RBAC, and multi-factor authentication. These tools help control who has access and how they access the system, reducing the chances of unauthorized entry. So overall, Azure Virtual Desktop combines flexibility, scalability, and strong security controls. Fill in the blanks by selecting the correct options from the drop-down menus. Azure resource groups are used to logically organize and manage resources, while management groups are used to organize subscriptions and enforce governance policies. Let's now go ahead and explain this clearly. In Azure, resource groups are containers that hold related resources like virtual machines, storage accounts, and databases. They're used for organizing and managing these resources in a logical way, often based on a common lifecycle, application, or environment like dev or production. On the other hand, management groups sit at a higher level in the Azure hierarchy. They are used to group multiple subscriptions together so that governance policies like role-based access control and Azure policy can be applied consistently across all those subscriptions. For example, if your company has separate subscriptions for different departments, management groups allow you to enforce policies across all of them at once, while resource groups let each department organize and control their own resources more effectively. And that completes this fill-in-the-blank question. For each Azure storage tool, drag it to the appropriate boxes in the correct match column based on its key characteristics. Each item may be used once, more than once, or not at all. Provides a graphical interface for managing Azure storage accounts, Azure Storage Explorer, a command line tool used for automating bulk data transfers. As copy allows users to create, view, and manage blob containers and files with a user-friendly interface. Azure Storage Explorer requires users to sign in using a web authentication process for command execution. As copy supports drag-and-drop functionality for uploading and downloading files. Azure Storage Explorer executes copy operations using AZ-copy CP command. Let's now explain each match in detail. Starting with Azure Storage Explorer, this tool offers a graphical user interface, making it easy for users to interact with Azure Storage without writing any code. It supports drag-and-drop uploads and allows you to explore containers, tables, and queues visually. This makes it especially useful for those who prefer GUI over command line tools. As copy, on the other hand, is built for automation and efficiency. It is a command line utility designed for high-performance data transfers between local environments and Azure storage. It supports commands like AZ copy CP, and is ideal for large-scale or script-driven file operations. Before executing commands, users need to authenticate through a web-based login, which adds a layer of security. Tools like Azure CLI and Azure PowerShell are more general purpose and don't focus specifically on storage operations, which is why they weren't matched in this activity. And that wraps up this Azure Storage Tools question. For each use case listed below the table, drag it to the appropriate boxes in the correct match column to match it against its example in the option column. Quickly create different OS configurations. The correct match is testing and development, recover from primary data center failure. The correct match is disaster recovery, easily delete VMs after testing. The correct match is testing and development, create temporary VMs for high demand. The correct match is disaster recovery, run multiple virtual networks. The correct match is testing and development. Now let's walk through the explanation for each of these. First, quickly creating different OS configurations is a classic scenario in testing and development environments where developers need to test software across various operating systems without starting from scratch each time. Next, recovering from a primary data center failure is clearly a disaster recovery use case. Azure allows organizations to quickly spin up virtual machines in secondary regions to keep services running. Now, when it comes to easily deleting VMs after testing, this flexibility makes testing environments cost-effective. You only pay for what you use and can remove resources as soon as tests are completed. Creating temporary VMs for high demand also fits disaster recovery because during outages or sudden usage spikes, these temporary machines help bridge the gap until the full environment is restored. Lastly, running multiple virtual networks supports testing and development, since isolated network setups are often needed to mimic real-world deployment scenarios without affecting production. And that's how you align these use cases with the correct categories. For each statement below, indicate whether the answer is true or false. The Azure Free Student Account provides free access to certain Azure services for 12 months. The answer is true. Students receive a $100 credit upon signing up for the Azure Free Student Account. The answer is true. A credit card is required to sign up for the Azure Free Student Account. The answer is false. The Azure Free Student Account provides access to free developer tools. The answer is true. Now, let's go through the explanation so you understand why each answer is correct. To begin with, Microsoft offers the Azure Free Student Account specifically to support students in learning cloud computing. It includes free access to popular Azure services for 12 months, giving students a chance to experiment and build real-world projects. Additionally, students receive $100 in Azure credits, which they can use to explore paid services beyond the free tier during that one-year period. Unlike the regular free Azure account, the student version does not require a credit card to sign up. This makes it more accessible and encourages students to learn without financial barriers. Finally, the student account includes access to developer tools like Visual Studio Code, GitHub Student Developer Pack, and others. These tools help students build, test, and deploy their applications efficiently. So overall, the Azure Student Offer is designed to promote hands-on learning without upfront costs. For each statement below, indicate whether the answer is true or false. Containers require users to manage the operating system for each container instance. The answer is false. Containers are more lightweight than virtual machines because they share the host OS. The answer is true. Azure Container Instances allow users to run containers without managing virtual machines. The answer is true. Docker is a popular container engine that is supported in Azure. The answer is true. Let's now explain each of these in a clear and logical way. First, containers don't require users to manage the operating system separately for each instance. Unlike virtual machines, containers share the host OS kernel, which simplifies management and reduces overhead. That's why the first statement is false. Next, because containers don't carry a full operating system like VMs do, they're significantly more lightweight. They start faster, consume fewer resources, and are easier to scale, which makes the second statement true. Moving on to Azure Container Instances, this service allows you to run containers without having to set up or manage virtual machines. It's a platform as a service offering designed to simplify container deployment, making the third statement true as well. And finally, Docker is one of the most widely used container engines across the industry. It's fully supported on Azure, making it a common choice for developers deploying containers in the cloud. That confirms the last statement is true. So, in summary, containers offer a more efficient and simplified approach to running applications, especially when combined with Azure's built-in support. For each statement below, indicate whether it is true or false. Block blobs are optimized for streaming large files. The answer is true. Page blobs are used for virtual machine disks in Azure. The answer is true. A blob container is a logical grouping of blob objects. The answer is true. Azure Blob Storage supports SMB file shares. The answer is false. Now let's explain these answers to help you understand them better. First, block blobs are indeed optimized for streaming and storing large objects like videos, images, and backups. They store data in blocks, making it easy to upload or modify large files efficiently. Secondly, page blobs are specifically designed for random read-write operations, which makes them perfect for Azure Virtual Machine disks. They support frequent updates to parts of the file, a key need for operating system and data disks. Next, when it comes to blob containers, they act like folders in Azure Storage. They organize and group related blob data, making management simpler, even though Azure Blob Storage itself doesn't use a traditional folder hierarchy. Lastly, Azure Blob Storage does not support the SMB protocol. Instead, SMB file shares are offered through Azure Files, which is designed for scenarios that need file system semantics and compatibility with Windows file sharing. So in summary, Azure Blob Storage is great for object storage, but if you need shared file access over SMB, you'll want to look at Azure Files instead. For each statement below, indicate whether the answer is true or false. Conditional access can be used to block access from unknown or unexpected locations. The answer is true. Conditional access automatically blocks all sign-in attempts from external identities. The answer is false. Organizations can use conditional access to enforce MFA for administrators while allowing regular users to log in with passwords only. The answer is true. If a conditional access policy requires a managed device, users must register their device before accessing resources. The answer is true. Now let's explain why these answers are correct. First, conditional access can indeed block access from unfamiliar or risky locations. This is part of its core functionality, evaluating sign-in conditions and enforcing restrictions based on location, risk level, or other factors. Next, while conditional access can be configured to restrict external identities, it does not automatically block them. The policy has to be explicitly created and applied. Otherwise, external users may still be granted access under permitted conditions. Moving on, conditional access provides granular control. That means you can apply different rules to different user groups. For example, admins can be required to use multi-factor authentication, while regular users might be allowed to sign in with just a password. And lastly, if a conditional access policy requires a device to be managed, users must register it through services like Microsoft Intune or Entra ID. Without registration, access to resources will be blocked according to the policy. So as you can see, conditional access is all about tailored control over how and when users can access resources. For each statement below, indicate whether the answer is true or false. Azure disks provide block-level storage for Azure virtual machines. The answer is true. Azure Table Storage is a relational database that supports SQL queries. The answer is false. Azure Managed Disks provide better availability and resiliency compared to traditional physical disks. The answer is true. Azure Blob Storage supports NoSQL data storage and is ideal for large-scale structured data. The answer is true. Now let's walk through the explanation together. First, Azure disks do provide block-level storage specifically optimized for virtual machines. This type of storage works like a traditional hard drive but is managed by Azure, making it ideal for VM-based workloads. Next, Azure Table Storage is not a relational database. It's a NoSQL key value store, so it doesn't support SQL queries. Instead, It's built for storing massive amounts of structured data without complex relationships, which is why that statement is false. Moving on, Azure Managed Disks are virtualized and come with added benefits like high availability, resiliency, and automated backups. These make them far more robust and scalable compared to traditional physical disks. Finally, because Azure Table Storage is a NoSQL option, it handles large-scale structured data very efficiently, especially when you don't need relational joins or advanced querying. So overall, these services are optimized for different purposes: Azure Disks for VMs and Azure Table for scalable NoSQL storage. Arrange the process of how Azure organizes its physical infrastructure and ensures resiliency in the correct order. Drag and drop the items into the correct order, starting with the first one at the top. 1. Data centers. 2. Availability zones. 3. Regions. 4. Region pairs. Now let's go ahead and explain why this is the correct sequence. Everything in Azure's infrastructure begins at the data center level. These are physical buildings that house the servers and network equipment. They're the foundational layer. Next, Azure groups data centers into availability zones. Each availability zone is made up of one or more data centers and is designed to be isolated from other zones to prevent a single point of failure. Then, multiple availability zones are grouped into a region. A region represents a specific geographic area, like West Europe or East US, where Microsoft has deployed its data center resources. Finally, Azure pairs regions together into what are called region pairs. These pairs are used for disaster recovery and high availability, ensuring that if one region goes down, the other can take over. So the structure flows logically from individual data centers up to broader geographic and redundancy planning through region pairs. Arrange the steps to interact with Azure CLI interactive mode. Instruction: drag and drop the items into the correct order, starting with the first step at the top. 1. Enter the command AZ-interactive in the CLI. 2. Decide whether to send telemetry data and enter yes or no. 3. Wait for the interactive mode to fully initialize. 4. Start typing commands with autocompletion by entering a command like AZA. 5. Use the arrow keys or tab to complete commands. 6. Exit the interactive mode by typing exit. Let's now walk through the steps so they make perfect sense. You begin by entering the command AZ-interactive in your terminal. This tells the Azure CLI to launch its interactive mode, which is great for beginners and those who want command suggestions in real time. Immediately after launching, Azure CLI may ask if you'd like to send telemetry data, which helps Microsoft improve the tool. You can type yes or no, depending on your preference. Once that's done, the system takes a few moments to fully initialize the interactive environment. When ready, it presents a prompt where you can begin entering commands. You can now start typing commands. For example, just typing AZA will prompt suggestions like AZ account or AZ-AKES, helping you find the right syntax quickly. To make this even smoother, the interface allows you to use arrow keys or the tab key to autocomplete commands, making exploration much easier. Finally, when you're done, you can simply exit by typing exit, and that ends the session cleanly. This flow ensures an intuitive and efficient command line experience in Azure. A software company wants to implement a microservice architecture for a web application, breaking it down into independent components that can be scaled and managed separately. Which Azure services would be suitable for this setup? Select two answers. A. Azure Kubernetes Service, AKS. B. Azure Container Apps. C. Azure Virtual Machines with multiple OS installations. D. Dedicated physical servers for each service. The correct answers are A. Azure Kubernetes Service, AKS, and B. Azure Container Apps. Let's now go through the explanation so it's easy to understand. Azure Kubernetes Service, or AKS, is built specifically to manage and orchestrate containers. In a microservices architecture, you have many small services working independently, and AKS helps automate deployment, scaling, and management of those services efficiently. In addition, Azure Container Apps is another great choice for this setup. It provides a serverless container environment that supports scaling, traffic splitting, and built-in load balancing, features that perfectly match the needs of a microservices design. On the other hand, Azure virtual machines with multiple OS installations are not ideal. They're heavier, require more manual management, and lack the agility and automation that containers offer. Likewise, dedicated physical servers are not flexible or scalable enough. Microservices benefit from rapid deployment and easy scaling, which containers provide, something physical servers simply don't match. So if you're planning to implement microservices on Azure, AKS and container apps are your go-to solutions. Azure services enable solutions that aren't feasible without the power of the cloud. Which of the following services exemplifies this by providing capabilities such as natural communication through vision, hearing, and speech? Select one answer. A. Azure Virtual Machines. B. Azure Cognitive Services. C. Azure Storage Solutions. D. Azure DevOps Services. The correct answer is B. Azure Cognitive Services. Now let's break down why that answer is the best fit. Azure Cognitive Services is specifically designed to provide artificial intelligence capabilities such as speech recognition, computer vision, language understanding, and more. These services enable applications to interact with users in a human-like way, for instance, translating spoken language in real time or analyzing sentiment in written text. In contrast, Azure Virtual Machines provide infrastructure resources, but do not include advanced AI features like natural language or speech processing. Similarly, Azure Storage Solutions are focused purely on storing and managing data, not interpreting it through vision or hearing. Azure DevOps Services, on the other hand, support software development processes like CI/CD pipelines, but they are unrelated to AI-driven interactions. So, when it comes to enabling advanced communication using cloud-based AI, Azure Cognitive Services is the clear and correct choice. For each statement below, indicate whether the answer is true or false. Virtual network peering allows two virtual networks to connect directly to each other. True. Virtual network peering enables traffic to flow between networks over the public internet. False. User-defined routes, UDR, allow administrators to control network traffic flow between subnets. True. Traffic between peered networks in Azure never leaves the Microsoft backbone network. True. Now let's go ahead and explain these answers. Virtual network peering allows direct communication between two Azure virtual networks without requiring a VPN or gateway, making the first statement true. The second statement is false, because traffic between peered virtual networks does not go over the public internet. It stays on Microsoft's private backbone network, which enhances both security and performance. The third statement is true since user-defined routes give administrators the ability to customize the traffic paths between subnets, improving network management and control. Finally, the last statement is true because Azure ensures that traffic between peered networks remains on its secure, high-speed backbone, reducing latency and avoiding exposure to the public internet. All of these are foundational networking features that help ensure security, efficiency, and control within Azure environments. What is the purpose of defense in depth? A. To enable you to locate and act on resources that are associated with specific workloads, environments, business units, and owners. B. To evaluate resources and make recommendations to help improve reliability and performance. C. To manage policies that control or audit resources so that the configurations stay compliant with corporate standards. D. To use several layers of protection to prevent information from being accessed by unauthorized users. Correct answer, D. Let's go ahead and explain this. Defense in depth is a security approach that uses multiple layers of protection to reduce the risk of unauthorized access. Even if one layer is compromised, the others still protect the system. This makes option D the correct choice. Option A describes resource tagging and management, which is more about organizing and tracking resources than securing them. Option B refers to Azure Advisor, a tool that helps optimize reliability and performance, not necessarily tied to the defense in-depth strategy. Option C reflects what Azure Policy does, ensuring compliance with configuration rules, but again, that's not the primary goal of defense in depth. So defense in depth is about layering protections like firewalls, access controls, and encryption to make it harder for attackers to succeed, even if they bypass one barrier. Which of the following is true about ExpressRoute? A. ExpressRoute connections use the public internet for data transfer. B. ExpressRoute enables private connections between on-premises networks and Microsoft Cloud services. C. ExpressRoute only supports connectivity to Azure services, not other Microsoft services. D. ExpressRoute does not support redundancy and high availability. Correct answer, B. Now let's break this down and explain. ExpressRoute is a service designed for private connections between your on-premises infrastructure and Microsoft Cloud services. Unlike traditional connections that use the public internet, ExpressRoute bypasses it entirely. This makes the connections not only more secure, but also more reliable and consistent in performance. That's why option B is the correct choice. Option A is incorrect because ExpressRoute avoids the public internet specifically to offer better security and performance. Option C might seem plausible at first, but it's wrong. ExpressRoute doesn't just connect to Azure, it also supports Microsoft services like Office 365 and Dynamics 365. Option D is also false because ExpressRoute includes redundancy and high availability features through multiple peering locations. That means if one path fails, another can take over. So, ExpressRoute is ideal when organizations need high throughput, low latency, and secure connectivity between their infrastructure and Microsoft's cloud services. You are setting up a VPN gateway between your on-premises data center and Azure. The network topology is expected to change frequently as new subnets are created, and you need a VPN solution that can adapt dynamically to these changes. Which VPN type should you use? A. Policy-based VPN. B. Point-to-site VPN. C. Route-based zone redundant VPN. Correct answer, C. Route-based VPN. Let's go ahead and explain why route-based VPN is the best fit here. Route-based VPNs use dynamic IP routing, which means they rely on routing tables to determine where traffic should go. Because of this flexibility, they are ideal when your network topology is changing often, like when subnets or routes are added or updated frequently. This dynamic nature makes route-based VPNs well-suited for enterprise environments that require scalability. Policy-based VPNs, in contrast, depend on static IPs and fixed configurations, making them less adaptive and better suited for stable environments. Point-to-site VPNs are used for connecting individual devices to the network, not for connecting entire networks to each other, so they don't meet the need in this scenario. Zone-redundant VPNs focus on high availability across different availability zones, which is useful for resilience, but has nothing to do with dynamically adapting to topology changes. So the best choice here, hands down, is route-based VPN. Your company is developing a new application that requires the following: execution of background tasks in response to specific events, minimal management of infrastructure, automatic scaling based on workload demand. Which Azure Compute services should you consider? Select two answers. A. Azure Virtual Machines. B. Azure Functions. C. Azure Container Instances. D. Azure App Service. Correct answers: B. Azure Functions. C. Azure Container Instances. Let's now go through the explanation. Azure Functions is a perfect fit when your app logic needs to respond to events or triggers like HTTP requests, file uploads, or timer-based schedules. It's serverless, which means you don't worry about provisioning or managing infrastructure, and it automatically scales with demand, ideal for background jobs. Similarly, Azure Container Instances provide a quick way to run containers without managing virtual machines. They're lightweight, fast to deploy, and scale as needed, making them a great choice when you want to offload infrastructure overhead but still need control over your runtime environment. In contrast, Azure Virtual Machines require you to manage everything from the OS to patches and scaling rules, which goes against the minimal infrastructure requirement. And while Azure App Service does offer auto-scaling and ease of deployment, it's mainly tailored for web apps and APIs, not general background tasks or containerized workloads. So if you want speed, flexibility, and serverless automation, Azure Functions and Azure Container Instances are the best picks. Which two factors impact the selection of an Azure region when deploying cloud resources? A. Distance from users to reduce latency. B. Availability of services and features in a region. C. The number of physical servers in a data center. D. The amount of water required to cool the data centers. Correct answers: A. Distance from users to reduce latency. B. Availability of services and features in a region. Let's break this down and explain. First, deploying resources closer to your users significantly reduces latency. This means your applications respond faster, improving user experience. So, Distance from users is definitely a key factor in region selection. Next, not every Azure service is available in every region. Some services, especially the latest ones, may be released gradually across regions. This means availability of services and features also plays a critical role. Now on to the incorrect options. The number of physical servers in a data center might affect capacity, but it isn't something you control or even need to consider when selecting a region. Azure manages that on their end. And finally, although cooling data centers is essential, the amount of water used for that purpose has no bearing on how you choose a region. So in summary, for performance and functionality, always consider proximity to users and what services are actually supported in the region. You need to manage Azure resources using Cloud Shell from the Azure portal. On the provided image, identify the correct icon to access Cloud Shell. Task, drag and drop the marker labeled "Click here" onto the correct icon within a red bordered area. In the Azure portal interface shown, Cloud Shell can be accessed via the icon in the top right corner of the portal. This icon looks like a terminal window. It is typically located near the search bar, represented by a command line prompt icon. This icon allows you to launch Cloud Shell directly, providing a browser-based command line interface for managing Azure resources. In this case, the correct area to place the "Click Here" marker is on this terminal-like icon in the top right corner. Fill in the blanks by selecting the correct options from the drop-down menus. The Azure portal is a web-based, unified console that provides an alternative to command line tools for managing Azure subscriptions and resources. Let me explain what this means. The Azure portal gives you a graphical interface to manage your cloud services. Instead of typing commands in a terminal, you can just click your way through settings, dashboards, and visual tools. Because it's web-based, you can access it from anywhere with a browser. And since it's unified, it brings together all services, whether you're deploying a virtual machine, configuring security settings, or checking your billing. On the other hand, the command line tools like Azure CLI or PowerShell are powerful, but they require you to know the syntax. So the portal provides a friendlier option, especially for those who prefer not to use command line interfaces. That's why web-based unified console and command line are the correct pair here. For each identity and access management IAM component, drag it to the appropriate boxes in the correct match column to match it against its description in the option column. The identity of a user, application, or service in Azure, Security Principal Identity, defines what actions a user or service can perform. Role-based access control, RBAC, determines which resources a role applies to. Scope inherits permissions from higher levels of the resource hierarchy, used to authenticate users and grant access to Azure resources. Security Principal Identity, a role-based model that assigns permissions to users and groups. Role-based access control, RBAC. Let's go ahead and explain each match, starting with Security Principal Identity. This refers to the entity that is requesting access, whether it's a user, an app, or a service. Since it represents the identity, it naturally matches the statement about identifying who or what is accessing Azure. It also fits with authenticating users, because before you assign any permission, Azure must know who is asking. Now let's look at RBAC. Role-based access control defines exactly what a user or service can do, like read, write, or delete a resource. That's why it correctly matches both defining user actions and the description of assigning permissions to users and groups. Finally, we have scope, which defines the boundary or level at which access is applied. For example, you can assign a role at a subscription level, a resource group, or directly to a resource. And because Azure uses a hierarchy, roles assigned at higher scopes automatically apply to lower scopes, making inherits permissions from higher levels. Also correct. So everything lines up perfectly with how IAM works in Azure. For each statement below, indicate whether the answer is true or false. Budget alerts notify users when spending exceeds a predefined budget limit. True credit alerts apply to all Azure subscriptions, including free trials. False department spending quota alerts are used in Enterprise Agreement, EA, subscriptions. True Azure automatically prevents users from exceeding their budget limit once an alert is triggered. False. Now let me explain each of these statements clearly. Budget alerts are designed to help you stay within your cost expectations by notifying you when your Azure usage reaches a specific threshold. This is why the first statement is true. However, credit alerts are only applicable to enterprise agreement subscriptions, so they don't apply to free trials or pay as you go subscriptions. That makes the second statement false. The third statement is true because department spending quota alerts are specifically built into the enterprise agreement model, where departments within an organization have assigned budgets, and alerts go out once usage nears or hits those limits. Finally, while alerts are useful, they do not automatically stop your Azure resources. The last statement is false because Azure just notifies you, but it's up to you or an automated action you've configured to stop or scale back resources. So to wrap up, the answers reflect how Azure helps monitor spending, but still leaves control in your hands unless automation is set up. For each statement below, indicate whether the answer is true or false. Azure Resource Manager, ARM, is responsible for handling all management requests for Azure resources. True ARM templates are written in YAML and are used to configure Azure resources. False. Azure Resource Manager allows users to manage resources using declarative JSON templates. True ARM templates ensure that Azure resources are deployed in a consistent and repeatable manner. True. Now, let's walk through the explanation for each of these. First, Azure Resource Manager, or ARM, acts as the core management layer in Azure. It handles all requests for resource creation, updating, and deletion, which includes managing authentication, authorization, and execution. That's why the first statement is true. Next, we have a common misconception. ARM templates are not written in YAML. Instead, they use JSON, which stands for JavaScript Object Notation. So the second statement is false because YAML is not supported for ARM templates. Moving on, the third statement is accurate. ARM uses declarative JSON templates to define infrastructure, allowing you to describe what you want to deploy without having to write the steps to do it. Finally, one of the key benefits of ARM templates is consistency. Every time you run a template, Azure deploys the same resources with the same configurations. That's why the fourth statement is also true. So, in summary, ARM helps you manage Azure consistently using JSON-based templates that promote repeatability and reduce configuration errors. An organization has deployed resources across multiple Azure regions for various business units. They need to generate cost and chargeback reporting to track Azure expenses for each business unit. Which Azure feature should they use to simplify this task? A. Tags. Resource locks. C. Resource groups. D. Management groups. The correct answer is tags. Now let's explain why this is the right choice. Tags in Azure allow you to assign metadata to resources in the form of key value pairs. These tags can include custom identifiers such as department names, cost centers, or project codes. That means even if your resources are scattered across regions or subscriptions, you can consistently apply a business unit tag and later filter costs by that tag in Azure Cost Management. On the other hand, resource locks are great for preventing accidental deletions or changes, but they have nothing to do with cost tracking. Similarly, resource groups are more about logical organization of related resources for deployment and management purposes, but they don't help categorize costs. Lastly, management groups are used to organize subscriptions at a higher level and apply policies, but they're not intended for tagging individual resources for reporting. So in a real-world scenario, if finance asks you to show how much marketing or HR spent last month in Azure, tags are your best tool for generating that report. A company is planning to optimize their Azure costs. They are currently using pay-as-you-go pricing and want to reduce costs for their consistent workloads. Which of the following solutions can help them achieve their goal? Select two answers. A, use reserved capacity for consistent workloads. B, implement auto-scaling for variable workloads. C, utilize Azure free trial subscription benefits. D, move data to lower-cost regions. The correct answers are use reserved capacity for consistent workloads and implement auto-scaling for variable workloads. Let me now explain why these two choices are correct. When a company knows its resource needs won't change much over time, using reserved capacity is a smart move. Azure offers discounts up to 72% when you commit to using a specific amount of resources for 1 or 3 years. So instead of paying the higher pay-as-you-go rate, you benefit from long-term savings on predictable usage. Now, for workloads that fluctuate, autoscaling is key. This feature automatically adjusts the amount of resources based on demand. So when usage is low, you consume fewer resources and pay less. But when demand spikes, Azure scales up to maintain performance, efficient and cost-effective. On the other hand, the Azure free trial is temporary and isn't a viable long-term cost optimization strategy. And while pricing varies by region, moving resources just to chase lower costs can backfire. It may increase latency or even break compliance rules depending on your industry or location. So combining reserved capacity for what you always need with auto scaling for what varies gives you the best balance of savings and flexibility. Which Azure tool is specifically designed to help users track and control cloud costs? Select one answer. A. Azure Monitor. B. Azure Advisor. C. Cost Management. D. Pricing Calculator. The correct answer is Cost Management. Now let's break it down so it makes perfect sense. Cost Management is the go-to Azure tool when it comes to monitoring, analyzing, controlling your cloud spending. It provides built-in features like cost analysis, budget tracking, like an alert creation to help users stay within budget and understand where their money is going. On the other hand, Azure Monitor is great for keeping tabs on the performance and health of your resources using metrics and logs, but it doesn't focus on cost control. While Azure Advisor does suggest ways to save money, it's more of a recommendation engine. It doesn't provide tools to track spending or set budgets directly. Lastly, the pricing calculator is helpful before deployment. It estimates the cost of services based on your configuration. However, it doesn't track ongoing expenses after resources are deployed. So in summary, cost management is your best tool for tracking and managing actual cloud expenses once you're running resources in Azure. Which of the following scenarios correctly demonstrate the use of conditional access? Select two answers. A user is required to complete multi-factor authentication (MFA) when accessing corporate apps from an unmanaged device. B. A user gains full access to corporate systems simply by signing in with a username and password. C. An organization blocks access to Microsoft 365 from outside the United States. D. A company allows all users to log in from any location without verification. The correct answers are A and C. Let me explain why those two are correct and the others are not. Conditional access is all about applying policies that adapt based on the user's context, like their location or the device they're using. So in option A, when a user tries to access apps from an unmanaged device, requiring MFA adds a layer of security, which is exactly what conditional access is designed for. Now for option C, blocking access to Microsoft 365 from outside the United States is a location-based policy. That's another textbook example of conditional access, where access is granted or denied depending on geographic location. However, option B is incorrect because conditional access strengthens security and simple username and password access isn't secure enough. It wouldn't meet conditional access standards. And option D, which allows users to log in from anywhere without any checks, actually goes against the principle of conditional access. Conditional access is meant to restrict or monitor access, not give open access. So, once again, the correct answers are A and C because they both demonstrate how access can be conditionally modified to enhance security. For each statement below, indicate whether the answer is true or false. Azure offers two types of resource locks, delete and read only. True, a delete lock prevents users from modifying a resource but allows them to delete it. False, a read-only lock prevents users from updating and deleting a resource but still allows them to read it. True, resource locks are inherited by all child resources when applied to a resource group. True. Let's now go through the explanation to help you understand why these answers are correct. Azure provides two types of resource locks. The delete lock prevents deletion but still allows reading and modifications. The read-only lock is stricter. It prevents both modifications and deletions, only allowing read access. So the first statement is true because those are indeed the two lock types. Moving on, the second statement is false. A delete lock doesn't stop you from modifying the resource. It just stops you from deleting it. So the claim that it allows deletion but prevents modification is actually the opposite of how it works. Next, the third statement is true. A read-only lock means exactly what it says. Users can read the resource, but they cannot update or delete it. Finally, the last statement is true as well. When a lock is applied at the resource group level, that lock cascades down and applies to every resource within that group, which ensures uniform protection. So again, the correct sequence is true, false, true, and true. You need to compare the costs of running an application in an on-premises data center with the costs of running the application in Azure. What should you use to assist you? A. Azure Advisor. B. Azure Cost Management. C. Azure Pricing Calculator. D. Total Cost of Ownership TCO Calculator. Correct answer. Let's now break this down to understand why option D is the right choice. The total cost of ownership calculator is specifically built for this type of comparison. It helps you estimate potential cost savings when moving workloads from on-premises environments to Azure. It includes key cost components like hardware, electricity, cooling, real estate, and even staff salaries, giving you a comprehensive view of the financial impact. Now, Azure Advisor is a useful tool, but its focus is on optimizing resources already in Azure. It won't help you evaluate the cost difference between on-premises and cloud environments. Azure Cost Management is also helpful, but it's primarily designed for tracking and managing current Azure spending, not for forecasting or comparing with on-prem costs. Lastly, the Azure Pricing Calculator can give you cost estimates for Azure services, but it doesn't provide a side-by-side comparison with on-prem infrastructure, which is what you need in this scenario. So again, the right tool for this task is the Total Cost of Ownership Calculator.